Hello everyone. In Geometry for CAT series, we are discussing questions based on quadrilaterals, and today we are going to continue from there. Let's try our first question. In the first question, it's regarding a rhombus which has a perimeter of 64 centimeter and a diagonal measuring 18 centimeter. What is the length in centimeters of the other diagonal? So basically, we have a rhombus something like this, and the perimeter is given 64 centimeter. So each side length will be 64 upon 4, which is equal to 16 centimeters. So this is 16, and a diagonal measuring 18 centimeters. So we can say, if I draw the diagonals, we know that in any rhombus, the diagonals are perpendicular to each other. So ABCD vertex O is the intersection point, and the diagonals also bisect each other. That means these two lengths will be equal. OA will be equal to OC and OB is equal to OD. Now, a diagonal measuring 18 centimeter. So if we say AC is equal to 18, can we say OA will be equal to 9? In that case, what we can say, OB will be equal to? OB will be equal to square root of AB square minus OA square, right? Using the Pythagoras theorem. Or this is equal to square root of 16 square, which is 256, OA square, which is 9 square is 81. This gives us, this is 5. 25 minus 8 is 17, which we can write as 25 into 7. 25 square root is 5. So 5 root 7 centimeter. This will be the length of OB. Now if I need to find the other diagonal, which is BD, BD will be twice of OB, which will give us 10 root 7 centimeter. So our answer is option D. All right. Next question, it says ABCD is a rectangle and E is a point inside it if AE is equal to 16 centimeter. So ABCD is a rectangle, A, B, C, D, and there is a point E. Okay, so if I join A, ED, EA, then I join EB, then EC. This point is E. Now it's given that AE is equal to 16, BE is equal to 20, then C is equal to 18. We need to find D. Let's say this is equal to X. Now, whenever you get situation like this in a rectangle where all interior angles are 90 degree, opposite sides are parallel and equal. So using British flag theorem, what we can say that DE square plus BE square will be equal to AE square plus CE square. From there, we can say X square plus B is given. B is nothing but 20. So it will be 400 is equal to AE, which is 16. So 256 plus CE, which is 18. 18 square is 324. So we can say X square will be equal to 580 minus 400, which is 180. Or we can say X will be equal to square root of, now 180 can be written as 36 into 5. So we can say X will be equal to 6 root 5 centimeter. And there you go. Now this British flag theorem is given by Pythagoras theorem and nothing else. If you join these lines, okay, so you can prove that this theorem is true just using the Pythagoras theorem, nothing else. Next question, it says in quadrilateral PQRS. So PQRS R and S. Okay. PQ is given, which is 8 centimeter. So PQ is 8, QR is 14, RS is 19, and PS is 12. Find the number of possible integral values of PR. So if I join PR, we need to find the number of possible integral values of PR. Now what we can say, that in triangle PQR, using the property of sides of a triangle, can we say PR will be greater than the absolute difference between the two sides, means 14 minus 6. PR will be greater than 14 minus 8, not 6. And it will be less than sum of the two sides, which is 14 plus 8. So from there, we can say PR will be greater than 6 and less than 22. So this is what we got, one result regarding PR. Now, if we check in triangle PSR, again we can say that PR will be greater than the difference between PS and SR. So 19 minus 12. PR will be greater than 19 minus 12 and less than 19 plus 12. So from there we can say PR will be greater than 7 and less than 31. Now again we got another result with respect to PR. Now if I merge these two, this one and this one, what we can say, that PR is greater than 6, PR is greater than 7. So ultimately we need to take that PR is greater than 7, PR is less than 22, PR is also less than 31. So PR is less than 22. If we are talking about integral values of PR, the least value will be 8. Then we can take 9 and so on till 21. So what will be the number of values from 8 to 21? 21 minus 7. So number of values we are getting is 14 different values of PR here. Next question, it says PQRS is a square, PR and SQ, both are the diagonals, intersects at point O. Bisector of angle QPR intersect OQ at M and QR at N. Find the ratio of OM is to NR. So let's try to draw the figure and try to understand what is being asked here. So this is a square PQRS. PR is nothing but the diagonal. QS is also nothing but the diagonal. So in that case, they are intersecting at point O. Now it says that the angle bisector of angle QPR is joining OQ at point M and QR at point N. So PN is the angle bisector. Now using angle bisector property, what do we know? That in any triangle, if there is an angle bisector like ABC triangle, D is an angle bisector, what we can say, that AB upon AC will be equal to BD upon DC. Let's say this is equal to X by Y. Then what we can say about DC? How do we find DC? Can we say DC will be equal to Y divided by X plus Y into BC? That is we are going to use here. Can we say the length PQ is equal to QR, or all the side lengths, let's say this is equal to A. In that case, the length of the diagonal, which is PR, is equal to QS. This will be equal to A root 2. And similarly, in any square, the diagonals are bisecting each other as well as perpendicular to each other. So we can say that OQ will be equal to OP, which will be half of this, half of the diagonal, which is equal to A upon root 2. Okay, now what we need to find? We need to find the length of OM. Think about this. Can we say if this length is X, this length is Y, then we can say OM will be equal to Y upon X. Now what will be Y? So QM is to OM is equal to PQ upon OP, right? PQ upon OP. And what is PQ upon OP? If PQ is A, then we can say OP will be equal to A by root 2. If this is A, this will be equal to A by A upon root 2. In that case, can we say that the ratio of QM is to OM, this will become 1 is to 1 by root 2 or root 2 is to 1. The ratio of QM is to OM is root 2 is to 1. So OM will be equal to 1 by root 2 plus 1 into length of OQ, which is equal to A upon root 2. This is our first result regarding OM. Similarly, can we say what will be the length of NR? To find the length of NR, first we need to find the ratio of QN is to NR. QN is to NR will be same as PQ is to PR. PQ is A, PR is A root 2. So the ratio will be 1 is to root 2. So in that case, NR will be equal to root 2 divided by root 2 plus 1 into the length of QR, which is nothing but A. This is our second equation. Just focus on this. If you have any confusion, try to understand from here. Now what we need to find? We need to find OM divided by NR. So this will be equal to this divided by this. What will happen? So A will be cancelled out. Root 2 plus 1 will be cancelled out. What do we get is 1 upon root 2 divided by root 2 upon 1, which is equal to 1 by 2. So our answer is option B. All right. This question says in the given figure, ABCD is a square with side 4 root 3 centimeter. So ABCD with side length 4 root 3. Triangle AQP and triangle CPD are equilateral triangles. Now find the area of that quadrilateral PSQR. This is what we need to find. Now can we say the length of DP will be equal to same as the side length, which is 4 root 3 centimeter. Now in any equilateral triangle, the interior angles are nothing but 60 degrees. So this will become 60 degree. This will also become 60 degree. Now using the concept of similarity, we can prove that PR is equal to PS, which is equal to SQ, which is equal to QR. Or you can just follow the symmetricity also. Both of them are equilateral triangle. The base is same, the height is same. So PR, PS, QS and QR, all of them will be equal, which makes it a rhombus. Now, in any triangle, can we say that if this is 60, this is 60, this angle must be 120 degree. So vertically opposite angle will also be 120 degree. And PR will be equal to, AR will be equal to RD. So these two angles will be 30 degree. So 120, 30, 30 triangles. The side ratio is 1 is to root 3. So this side length will be 4. Now already we know that PD is equal to 4 root 3. Can we say RD is equal to 4? So PR will be equal to 4 root 3 minus 4, right? Which we can write as 4 into root 3 minus 1. So what will be the area of the rhombus PSQR? This will be equal to product of two adjacent sides into the angle between, sine of angle between them. So it will be equal to 4 into 4, not 4. The side length is 4 root 3 minus 1. So 4 root 3 minus 1 square into sine root 3 upon 2. So 4 square is 16, 3 plus 1 4 minus 2 root 3 into, this is sine 60 degree, which is root 3 by 2. So let's put root 3 by 2, this will become 8, which gives us 8 into 4, 24, 32 root 3 minus, this will be 48. So our answer is 32 root 3 minus 48, which is option A. So with that, we are done with one more session of geometry for CAT series. Thank you.